Hello everyone, welcome to a new mathematics class. Today we are going to learn the second chapter of your textbook named whole numbers. Before learning about whole numbers, just see what we have learned in natural numbers or what are natural numbers. Before learning a new thing, we should have a complete knowledge about the previous thing. So I am just going to refresh your mind. So listen very carefully. We are just going to discuss about natural numbers. Natural numbers, the word itself says the numbers that is occurred naturally in our earth is called as natural numbers. Okay, for example, if you want to count how many students are there in the class, how will you begin? Will you begin 3, 4, 5? Is it so? No, we will begin from the first natural number, that is 1. We will count as 1, 2, 3, 4, etc. Right? Yes, that set of numbers or that collection of numbers are called as natural numbers. So we can say natural numbers are the numbers starting from 1. Then what is the next natural number? 2, 3, 4. And can you guess what is the last natural number? No. There is no end to the collection or the arrangement of natural numbers. So it goes on. Now let's see what is successor and predecessor. That's the third point that we need to discuss before whole numbers. Before beginning or getting into whole numbers, I just want to know you what is successor and predecessor. It's very important and very simple term. Successor means, for example, think of any natural number. For example, 4. The successor of the number 4 is 5. I hope you have understood what is successor. So, successor is obtained by adding 1 to the number that is with us. For example, if you are taking 99, what is the next number? To get the successor of 99, the successor is 99 plus 1, that is 100. So I hope you got what is successor. So can you say what is the successor of 10? What is it? Yes, 10 plus 1, that is 11. Now successor of 20 is 20 plus 1, 21. Now let's see what is predecessor. You would have already got the concept predecessor in your mind. Let's confirm it. Take the same number 99. The predecessor will be obtained by subtracting 1 from the number that is with us. For example, 99, the predecessor of 99 is 99 minus 1, that is 98. So, I am going to give you a small question. Does every number in the collection of natural number have a successor? That is, if you take any natural number, can you find the successor of that particular number? I will give you an example. Explain with an example. If you take number 2, can you find the successor? Of course, the number successor or the successor of the number 2 is 3. Now, another question. So that's true. Every number in or every natural number has a successor. Now, my second question is, does every natural number have a predecessor? Does every natural number have a predecessor? That is, if you take any natural number, can you find a number before the same? For example, if you take 4, of course 4 has a predecessor. Who is that? 3. Now, is this statement true for all the numbers? Exactly no. Why? Because there is no predecessor for 1. There is no predecessor for 1. In natural numbers, we don't have a predecessor for the number 1. Then comes a new variety of collection of numbers called as whole numbers. So let's write. This is a new, maybe a new term for you. Some would have already learned, but no problem even if you are hearing it for the first time. Whole numbers is defined as 0 added to the natural numbers. 0 added to the natural numbers. Can you find a 0 in natural number? No, there is no 0 in natural numbers. But if we add a 0, then keep on writing the natural numbers, then we get the collection of whole numbers. I hope you understood the difference, natural numbers and whole numbers. So, who is the predecessor of 1 in whole number? Yes, in whole numbers, the number 1 has the predecessor, and who is that? 0. Another question would be in your mind, what will be the predecessor of the number 0? There is no predecessor for the number 0 in whole numbers. Let it be taken into a next, that will be learned by you in the next or coming years. For the time being, let's understand that whole numbers are the collection of numbers including 0 and natural numbers. I hope you understood this much. So let's move on to the next portion, number line. So let's see what is a number line, or how can we draw a number line. Let's see how it can be done. First step, draw a line, mark a point. So this is the first step. We should draw a line. I have already completed the whole step. For your information, I am going to do this one. This is a line, and mark a point. So I have marked a point. Label it as 0. So this is the labeling I have done. 0, since it is a line, we are going to extend it in both sides. So this is the point 0. Second step, mark out points to the right of 0. So this is our point 0, and mark out points to the right of 0 at equal intervals. So I am going to mark out points at equal intervals. So the distance between the first mark and the distance between first and second mark should be the same, and so on. And what's the last step? Label them as 1, 2, 3, 4, etc. So this is 1, 2, 3, 4, and you're done. So this is your number line. I have completely made a complete step or a big number line. Please look at the number line that's in your whiteboard. So this is how it works. This is the point 0, and marking out points to right of 0. So this is the right side of 0 at equal intervals. So this distance and all the distance between the simultaneous or the pair of numbers should be the same. That is the distance between these two and these two and these two. So whichever number that comes together, the distance between them should be always same. And this is how number line is drawn. And this is a number line with whole numbers represented on it. What type of numbers are these? Are they natural numbers? No. If 0 is included in the collection of numbers, it is no longer natural numbers. That is the collection of whole numbers. This is clearly a collection of whole numbers being represented in a number line. I hope you understood. Please read the steps and prepare your notes. By seeing this video itself, you won't be given notes. So make sure you have copied this in your notebook. So I hope you have understood what is a number line and how to draw a number line. Now let's see what are the help that the number line gives us. Basically, we can do addition, subtraction and multiplication using number line. Can you think how? Or do you wonder how this can be done? Let's see. The first step, addition. To do addition, it corresponds to moving right. Yes, moving right on the number line. That's called addition. You may be wondering how. I will give you an example. So I'm going to represent the first one, example 1. If you want to add two numbers, say any two numbers, maybe 10 and 2. You know what is the result of 10 and 2? While you were small kids, we were small kids, we used to calculate in our hand or in our fingers. Do you remember that? Yes. If you want to add 3 and 4, first we used to take 3 in our right hand. This is 3. And when the teacher or your parents ask you to add 4 to the number 3, then you will immediately add 1, 2, 3, 4. The answer is 7. Maybe this will be more helpful for you. I know you don't need to use number line at this age, but still we are going to see what is the use of number line. Let's see how this one is. 10 plus 2. You all know the answer that 10 plus 2 is 12. Now let's see or solve using the help of number line. Where is number 10 located? Here is our number 10. Now, what was the question in front of us? We just need to add 2 to the number 10. And if the process is addition, what is the step that we should follow? it corresponds to moving right on the number line. And how many movements do we need to make? 2 movements. Let's see. This is our point 10. 2 movements means 11, 12. So here is your answer. 10 plus 2 is 12. Another example. 7 plus 6. What is the value of 7 plus 6? Let's find out from the number line. Here is our 7. How many movements do we need to make? 6 continuous movements. This is 1, 2. Count with me. How many has it gone? 1, 2, 3, 4, 5, 6. So the answer is 13. 7 plus 6 is 13. I hope you understood this one. Now let's see the second process, subtraction. I'm going to give you the second examples. Let's see. Say the same numbers. 10 minus 2. What is the value of 10 minus 2? And to do the process of subtraction, what is the general principle that we have? Subtraction corresponds to moving left on the number line. So this is our number line, and what are we asked to find? Subtract 10 or subtract 2 from 10. So where is number 10? Here is our number 10. And how much do we need to subtract? We just need to subtract 2 from the 10. And what's the rule? Moving left on the number line. So here is our 10. There is one movement, and here is the second movement, and here is your final answer. 10 minus 2 is 8. Now the next question. 7 minus 6. Let's see how this is done. 7 minus 6. Where is our 7? Yes, here it is. We are going to subtract a percent 6 from 7. So this is subtraction of 6, and I repeat, the rule is to move left on the number line. 1, 2, 3, 4, 5 and 6. So the answer is, who is that? 1. So 7 minus 6 is 1. Do you understand? Okay, good. Now let's see the third property or third example. We are going to see a set of examples. And third process or third operation that we are going to discuss is multiplication. This is a bit interesting one. In this case, if the multiplication comes, then we should make jumps of equal distance starting from 0. Jumps of equal distance starting from 0. Let's see how this is done. We will explain with an example of, or using an example. 2 times 4. 2 times 4. We all know the value that 2 times 4 is 8. 2 times 4 is 8. Now let's see how this is going to be. This is going to be fun. Let's see how it is done. 2 times 4 means we need to make 2 jumps of 4 units. 2 jumps of 4 units starting from 0. I repeat, multiplication corresponds to making jumps of equal distance starting from 0. So I am going to make 2 jumps of 4 units. Unit means the distance between two adjacent numbers is called as a unit. This is 1 unit, 1 unit, 1 unit, 1 unit. Every point is 1 unit. Now, what is the distance between 0 and 2? It is 2 units. 0 and 3, 3 units. Now the question is to find the value of 2 times 4. So we need to make 2 jumps of 4 units. So I am going to make the first jump. And where should it start from? From 0. Here is your first jump. Okay. And we have reached safely. And how many jumps do we need to make? 2 of them. So I am going to take the next jump. The next jump also should be of 4 units. So this is your second jump. And yes, 1, 2, 3. 1, 2, 3, 4. Yes, 4 units has been covered. And where have we reached? We have reached the value 8. Let's see another example. 5 times 3. 5 times 3. Let's make 5 jumps of 3 units. So this is the beginning point. First jump should be of 3 units. So I am making a jump Okay, this is your first jump. Now, second jump. This is also 3 units. Okay, 1, 2, 3. Now, third jump is also should be of 3 units. 1, 2, 3. So we should reach here. This is our third jump. Next jump should also be 3 units. 1, 2, 3. So this is our fourth jump. Now, one more jump is needed. I'm going to jump a unit of 3. 1, 2, 3. So it is here where we reach. And what's the value? It is 50. Now do one thing, everyone create your own examples and try to solve by your own. I hope this is clear. Then please note down in your notebook. We will move on to the next section after this one. I hope you understood how to do addition, subtraction and multiplication using number line. Now let's see a small portion called division by zero in this chapter. This is an important, not a question or it's not a topic that you will be asked in the examination. But as a mathematics students, you are supposed to know this kind of ideas. So let's see how or what is the idea of division by zero. First of all, what is division of a number? We should understand that. For example, I will represent using an example. Suppose we want to divide 12 by 4. We all know what is the value of 12 by 4. The answer is 3. 3 times 4 is 12 and the answer becomes, or the remainder becomes 0. This just means that how many times 4 should be added to get 12. Am I right? How many times 4 should be added to get 12? That is what 12 by 4 means. How many times we should add the person in the denominator to get the numerator? That will be 3. Let's see whether it is true or false. The denominator is 4. How many times 4 should, what is this, what it says? How many times 4 should be added to get 12? And the answer says it's 3. Let's verify that. 3 times 4 plus 4 plus 4. Will we get 12? 4 plus 4 is 8. 8 plus 4 is 12. So this is true. Let's see another one. 30 upon 6. 30 divided by 6. You know the answer is 5. That is 6 should be added 5 times to get 30. Let's see. 6 plus 6 plus 6 plus 6 plus 6. What is that? 6 plus 6 is 12. 12 plus 6 is 18. 18 plus 6 is 24. 24 plus 6 is 30. So the answer is correct. How many times? 5 times. How many times over here? 3 times. So basically, this is the idea of division. If anyone who is still having a lesser idea of this one, please confirm this. This is the principle or concept behind the division process. Now comes the heading or the relevant topic, division by 0. Can we divide any number by 0? Let's see. Suppose here is a question. 1 divided by 0. I repeat, 12 by 4 means how many times the denominator person should be added up to get the numerator person. How many times 4 should be added to get 12. Use the same idea and please come here. How many times, who is the denominator? It's 0. How many times 0 should be added to get 1? Is that possible? If we add 10 0, 0 plus 0 plus 0 plus 10 times 0, will we get any further number than 0? No. If we add 100 zeros, 1000, 10,000, crores, lakhs of crores, we don't know. So, we cannot predict what is the principle behind this one. So, just understand this. Division by 0 is not possible. So, this is the last idea that we should have on this topic, division by 0 is not defined. So keep this in your mind. We cannot divide any number by 0. We cannot divide 0 by, or this is the thing, we cannot divide by 0. We cannot divide by 0. That's all. Now 2 by 0, 3 by 0. These all are not possible, or it's not defined. Another thing, we used to represent by a symbol to do our problems. Let's see what is that. Suppose we have a problem 1 upon 0 or 1 by 0. We don't know. Just as we said here, division by 0 is not defined. So what we need to do is that this can be approximated to infinity. That is, if we add infinite number of zeros, we might get a number in the denominator. But this is mathematically wrong. We cannot say 1 by 0 is infinity. For just your concept, you can write 1 by 0 is equal to infinity. Even though it's not precise, or even though it is not correct, for doing problems only you can use this symbol. You will use these symbols in your higher mathematics a lot. So I am saying just as a point over here. So you can note this one approximately, or you can say not mathematically precise. Precise means correct or clear. Okay, so that's it. 1 by 0 can be written as infinity for mathematical or while doing problems. That's all. So this ends our first part of your second chapter, whole numbers. And please write down all the notes and do the exercise 2.1 by yourself. Thank you.